Hello everyone, good evening. So far we only have a handful of candidates. Ritik, Pranav and Sudarshan, can you guys inform your peers to join maybe in the next 5 minutes? Hello guys, am I audible?
Yes, we are.
Yeah, Ritik, can you ask everyone else to join as many as possible and in the next
Yes.
5 to 10 minutes? Because we are going to have the introduction to NoSQL databases. I guess it will be good to have more people around. Yeah, let's get started. I think we have the people joining. I don't think more people will be joining after this. Anyways, so we are going to start with NoSQL databases. So far, you have learned relational databases or otherwise also known as SQL databases. Uh, so what are the two types of databases and what is the broad level of difference between them? Can anyone chime? SQL and NoSQL databases. What is the basic difference between the two? Anyone? Guys, I hope I'm audible. Can anyone tell or give it a try?
MySQL databases are relational databases where we are storing the data in the form of relations, like ro- rows and columns. Am I audible?
Yes, yes, yes. Continue.
Yeah, yeah. So in NoSQL, there is no predefined schema for the data. So basically, the data that we are capturing from the web and social media sites and all. So we are not having a predefined like what kind of data will come. While in the case of relational database, we are already having a predefined database like data types of the columns and all that we are gonna save in that format.
But we can create a format for data coming in through social media, right?
But we cannot define predefine like what kind of data it will come. So we are
Why not?
saving.
We
So
can, if it's Facebook, I dictate what a post will look like. A post will have comments, comments will have replies. This, I will, as the creator of Facebook, I will dictate that. It's not that
okay.
people dictate what will a post look like, right?
For example, in one comment, if you don't know whether I'm gonna put there some text or I'm going to insert one image there or maybe some other
No
format.
worries, no worries. I will take the data type as a blob. It can
Yeah,
accommodate everything. Then
but I don't think that is possible in a relational database, right?
it is
We
very
need.
well possible. How do you think all these blogging websites worked before NoSQL database? In fact, you will be surprised to find out most social media websites, even YouTube, uses relational database only in the backend, not NoSQL database.
How will I decide that to which column I should map this particular info?
To which column means you can have a column called comments and map it. To which data type you mean?
Yeah.
Data type will be blob, right? I told you. Binary large object can take in any data format, image, text, anything.
Mm-hmm. So major difference I can say that row and the columns in the form of relations we are saving there and in NoSQL it's not like that. This
That
is
is
my
that is a difference. Yes, that is a legitimate difference. You have a predefined structure that all relational databases follow. Not only MySQL, not only Postgres. If it is a relational database like Oracle, MySQL, SQL Server, Postgres, it is bound to follow the tabular structure that we are familiar with for storing data, rows and columns. It cannot be any other structure. It cannot be that, oh, instead of a table, it is following a cube. Can't be the case. It's predefined, it will follow, and not only tabular structure, it will follow the broad construct of SQL query language, right? You will query the data from relational databases using SQL. Do we use anything else? There can be different variations of SQL, yes, but the broad standard is SQL, correct? But in non-relational database, it is not standardized. MongoDB has MongoQL, Mongo query language. Cassandra has its own query language. Redis has its own querying format. So different, and then the type in which data is stored over there is also different, right? Some databases follow wide column format, some databases follow document oriented format. In NoSQL, I'm talking about, there is no standard way of storing data. So a very easy way to understand non-relational or NoSQL databases is anything that is not SQL falls into the bucket or category of NoSQL databases. Anything that is NoSQL. Got it? I hope that is clear.
Means no SQL database will not use SQL, right? That's what
Correct.
you are saying.
Yes, not use SQL or not use that tabular structure.
Okay.
Okay. I hope this is clear about NoSQL databases. Yes or no, guys?
Yes.
The basic, if anyone asks you, then the easiest definition to give for NoSQL databases is what? What is it, guys? Yes, how will you define NoSQL databases?
All other databases that are not using SQL.
That are not using the SQL standard or the concept of relational databases. Right? Everything that falls outside the bucket of relational database comes under NoSQL database. NoSQL, as the name suggests. Clear?
Yeah.
Yes.
Is it
So
not
it is
only
very. Sorry.
is it not only SQL with the full form?
There is no full form as such. It's NoSQL. NoSQL is a name given like by popularity. There is no technical term like relational database is a technical term or SQL is a technical term. There is no technical term like NoSQL. It's basically absence of SQL. That's why it's called NoSQL. Okay. There is
But
no
we
technical term.
extract the data with this SQL queries only, or I mean, is it some other?
No. As I was telling, right, it will depend on the non-relational database that you are using. If it is MongoDB, you will use MongoQL. SQL
Okay,
doesn't come into picture with
no
any
SQL.
non-relational database because for
Mm-hmm.
SQL to work, it needs the concept of relations, foreign keys, primary keys, tabular structure, because that doesn't exist in the first place, right? The very definition of NoSQL database is data is not in that format. So you can't use SQL. You are getting it, right? Very simple reason. Clear?
Clear, sir.
Yes. And just to give you a bit of a foresight, and Sudarshan, I hope your doubt is also clarified through this. Okay, and just to give you a bit more of context, there is a third category as well, okay, which is known as GraphQL. Now, don't be confused. It isn't a database technology. GraphQL, although the name QL is there, so you might be tempted to think that it's a database technology just like SQL or NoSQL. No, that's not the case. It's an alternative for REST API. So that goes into the web development side of things. It is actually not much related to databases. GraphQL needs an underlying database to work with. It needs either a SQL database or a NoSQL database, doesn't matter, but it needs a database to work with. So unless you have an existing database, GraphQL doesn't do anything. GraphQL is a way to, or you can say a layer of abstraction sits on top of existing database, makes or gives you a different approach to get data from the database or to interact with the database. So GraphQL isn't a database technology as such by in and of itself. You might be hearing the word, but that's a bit of a misleading term. It's not a database technology as such. It's pioneered by Facebook. It's just a different way of managing large and connected multiple databases together in an easier to manage way. That's the basic purpose of GraphQL. So GraphQL isn't much necessary when you are dealing primarily with databases, because anyways to use GraphQL also you need some database to be there. So we'll focus on databases. Learning GraphQL isn't that big of a deal. It's just learning a bunch of syntaxes that will make your life easier, especially if you're dealing with a large scale application. Like a social media app, which uses geographically distributed databases, replicas, and multiple tables, large scale data coming in, going out of the database. Okay, so I hope no one will be confused with GraphQL as well. Clear? Okay, let me then show you the landscape of NoSQL database. It's not as easy to directly get into NoSQL databases. We will have to pick one. Each NoSQL database is actually not a bit, in fact, very different from each other. There is nothing almost in common between different NoSQL databases other than the fact that they don't use SQL. Okay. Other than this one simple concept, there is in fact nothing much in common between different NoSQL databases. So let me show you an image that will quickly encapsulate the whole difference, because it is the study of NoSQL, or the need for NoSQL arises from the demerits of SQL databases. Okay. So first we should know the demerits of SQL databases. Why SQL is not perfect? Why did we need something like NoSQL? Then we'll get into the different types of NoSQL databases. So, before looking at this image, can anyone tell me some disadvantages or drawbacks of NoSQL databases? No, sorry. So of traditional SQL databases, what are some drawbacks for which people had to think of other approaches?
Structured form alone, the data can be stored in structured alone.
As in? Elaborate on that a bit. How is that a disadvantage?
In the sense, it can only be in tabular form. So other than that, it cannot be in any other form, like what to say, so completely
Huh.
descriptive or a
That is
graphical or
correct.
image.
So your data is structured and a strict or concrete structure, right? That's what you are saying. So how is that a drawback? One can argue that is an advantage, that all your data will follow certain structures that you set. How is that a drawback?
So if I'm working on a data set which is completely in an image form, it is completely in a structural or a document form, say for example in NLP or an application wise. So SQL cannot help for me to inject those data into the SQL server and work on them.
Why
So
not?
for the, yep. Hello.
SQL can handle image data very well.
Oh, sorry for that.
No, see, and it's a good point that you have brought up. Many people think, like also a few minutes ago, Gitika was saying that I have images in comments, so I can store images easier in MongoDB or NoSQL database. One thing to keep in mind is multimedia files. Okay, you thought about images. Now think about YouTube videos. Do you think videos are stored in databases? If you store videos in database, how will you store them? You will convert an image, can be converted to, let's say, text binary or anything, and store it. Now think about a 1 hour video or even longer movies, or 10 hour long, let's say, uh, sessions. So the video itself is just a bunch of images and so many images together. Do you think it's efficient to store and retrieve it from database? One whole video being stored as one cell, or audio also in that, for that fact. A very simple thing is, basics of computer science is, you can store an image or an audio or a video or anything for that matter in binary format in database. Yes, because at the end of the day, everything is just 0 and 1. You can store it, and then there are encoding mechanisms to make it smaller. If you have gone through algorithms, you will be knowing a few, but it's highly inefficient. It's susceptible to corruption. It's a waste of resources, money. It's going to cost you a bomb if you decide to do that, no matter which organization you are. We never store images, videos, audio, or any multimedia content for that matter, or any large form content, anything that is very large in size, in databases directly. We store them in simple file storage, like S3 bucket, S3 buckets in Amazon, or let's say Azure Blob Storage, or maybe simple file systems, let's say Google Drive. Consider Google Drive only for understanding. We will upload, let's say, as YouTube, consider Google Drive. Any video that people upload, Google will upload them to Google Drive. Whenever you upload a file to Google Drive, you get a unique URL, right? You get a unique URL, be it an audio or a video or an image. You will take that URL and store the URL only in the database. You will never store the full multimedia file in the database. Can do that, but it's a very silly thing to do. Very, very inefficient. And I think you can imagine why. Encoding and decoding such a long binary file is not a good idea. So it's better to store it in file storage where you do not need to encode and decode. It's natural to store large documents in file systems and then take the path or the URL, store that URL in the database. So that's what happens. Doesn't matter if it's a profile image or a YouTube video or an audio or a GIF in a comment. It's very simple to store it in a file storage, take the URL and store it there. Do you get it? That's why you will notice whenever you are loading, let's say pages like Wikipedia or YouTube, the text content comes first. And it takes a while for the video to render because that's an additional step. It will get the URL from the database, then it will hit that URL, the file system, and then get the multimedia content from there. So images load a bit later after web pages. Same goes for audio, same goes for videos also. I hope that is very clear to everyone. It's a very fundamental concept of databases. Is that clear, guys?
Yes, yes.
Okay, so we never store. So the need for multimedia storage is not something that ushered in NoSQL databases. It is actually the restrictions that come with using SQL databases, like having to follow let's take a simple example. Let's say there is a table where a lot of columns are optional. Okay. Example can be, let's say, Facebook profile data. You need to give your email ID, you need to give your first name, you need to give, let's say, one or two other details like your phone number and all. But rest everything, your bio, your country, your everything, you can leave it empty, right? A lot of fields are optional, correct? You can choose to fill them if you want to. You can choose to ignore them if you don't want to. Even in LinkedIn, a lot of social media sites have most of the things as optional other than the mandatory details. So in that case, if you're storing it in a table format where, let's say, user details is the name of the table, lot of fields will be optional. And let's say one user will have, for hypothetically speaking, let's say you have 10 or 15 columns in that table, user details table. One user can have 2 columns data filled. One user can have 10 columns data filled, correct? So what will be the issue here? If we scale this up to 100 or million users.
Lot of space will be wasted.
Come again? Lot of?
Space will be wasted.
Yes, true. And if you take a look at the table, is it not wasted storage, wasted processing, right? You are going through large rows unnecessarily whenever you are doing any operations, not needed. You are wasting space, processing power, everything. What if I can store just the data that the user has provided as it is in the database? If a user has provided 3 attributes, I will store only 3 attributes worth of data. If a user has provided 10 or 12 or 15 attributes, I'll store that. What if I had that flexibility? Keyword here is flexibility. See, flexibility comes up as the third keyword, right? So flexibility is the primary motivating factor behind people striving for NoSQL databases. That flexibility in unit storage, which is not there in structured tables. You have to follow the same structure. Doesn't matter if you have the data, if you don't have the data. Each row will contain 15 columns for sure. The columns can be empty, but each row is bound to contain 15 columns in SQL databases. Whereas in, let's say, MongoDB, a document need not have 15 attributes. If you only have 3 details, it can only have 3 fields. If someone has 10 fields worth of details, 10 fields can be there. So that flexibility is the main reason why people even ventured out of SQL. And this started to research in this direction. NoSQL databases are a concept after the 2000s, and they have been popular only after 2010. And I will just give you some spoilers. They have been declining in popularity again after 2018-19, because a lot of things they promised uh, have simply not come to fruition, and people found better value going for SQL databases by using something for easier access such as GraphQL on top of it. And SQL databases also improved a lot in terms of flexibility, in terms of speed, performances, as they evolved in versions. So people again started to go back to SQL databases. That's why currently the most popularly adopted new database is Postgres, not MongoDB, not Cassandra, nothing. It's again Postgres. It would have been MySQL if it would not have been acquired by Oracle, but it's again relational databases which are popular. So just to sum up the differences between SQL and NoSQL databases, right? So you have relations or schemas in SQL databases. You do not have them in NoSQL databases. You have tables as the unit of storage in SQL databases. In NoSQL, you do not have any such fixed or rigid structure, but you do have some base structure, reference structure, like a document in MongoDB, a wide column in Cassandra, a key value pair in Redis. You do have some base structure, but that's not a strict or rigid structure like a table, right? So flexibility is non-existent in SQL. It's very dynamic or flexible in NoSQL side of things. Now, let's come to the disadvantages of NoSQL. From here on starts the disadvantages. One of the properties or bunch of properties that is guaranteed by SQL databases is ACID property, right? No matter which SQL database you use, you are guaranteed to have ACID property. Have you seen any SQL database which does not guarantee ACID property? That simply cannot be the case. If you're following SQL, you are bound to get ACID property, guaranteed. But none of the NoSQL databases, many have tried, but none of the NoSQL databases guarantee you ACID property. The one that comes the closest is MongoDB, kind of guarantees you 90%, but it has been found to also fail in some cases. So it cannot 100% absolutely guarantee with certainty that you will get ACID property. So they have come up with their own set of properties known as base, which even in fact doesn't make much sense. They've just made a term for the sake of making it, to be honest. But they do not or are not able to give you ACID property guaranteed. So that's a disadvantage. Again, data consistency, right? It's very, very high, strong in SQL databases. You do not have to worry much about data consistency. NoSQL, the way they say is, we cannot guarantee consistency of data to you. Data might be consistent, data might be corrupted, might get corrupted, high chances. As and when you start storing more and more data and when you start using the NoSQL database more, it will become more consistent. So they give you eventual consistency. That's the E in base. Actually, it's not consistent, it's eventual consistency. It's like share market. They tell nobody guarantees you 30% return. They tell you as and when you do mutual funds, if you keep investing for more years, your return percentages will go up. So eventually higher returns, not guaranteed higher returns. Whereas a SQL database is like a fixed deposit, 8% guaranteed every year. There is no change in that. So it's eventually consistent, but when you are dealing at the size of organizations and enterprises, they are not willing to bet on this eventual consistency. For them, even is for a bank, let's say data is not consistent. One or two transactions out of 100 are not consistently stored in the database. Something goes wrong. Do you think a bank can afford that kind of leniency? It cannot, right? Maybe one or two comments not appearing on YouTube or characters missing is something YouTube can afford. It won't affect its business. But for a bank, even a single transaction is important. So why will they risk it with NoSQL databases? Uh, Availability means, let's say you are running your database for 365 days or in a day for 24 hours. How many hours is it up and how many hours is it down, or because of server issues or some technical issues? So SQL databases are rarely down. They are consistent. They are consistently up or available. They have very less risks in that regard for downtime. But NoSQL databases, since they are newer, it's a simple function of maturity, because SQL databases have been around for 30, 40 plus years. So most of the bugs have been fixed. There's a large community support. Issues are known. Resolutions are known. It's easier to handle them as an administrator as well. But NoSQL are new. Issues might come up. Not every issue is known. lesser community support. So it's not as highly available as SQL database. And then, of course, scale. It's very easy to scale up a SQL database vertically. You can just keep on adding more rows, more rows, more rows to a table. There's no end to it till your memory permits. A NoSQL database, if you keep on adding more documents to a NoSQL database, to a MongoDB DB, its performance will take a hit. SQL database, not so much. If you keep on adding rows, it's not that its performance will keep on reducing drastically, but a NoSQL database will. So it's horizontally scaled rather than vertically scaled. So you'll have to change the way of storing data as well in NoSQL database. And these are a few types of NoSQL database. There are more, but these are a few common types. One is key value pair. So it stores data in the form of a simple key value or map or a hash table. So an example of this would be Redis or Memcached. These are NoSQL databases. And then wide column format, it's two column data. One column is, you can consider that as an index or a discovery column. Another one is a wide column where, let's say, you will fit in all the data. Let's say separated by commas or something. Say in the second column, you will fill all the data. So it's a 2D version key value, but the second value, second column will contain multiple data attributes separated by some separator. So that's a wide column format. Popular example is Cassandra. There is also a wide column database by Google. That's also very popular. And then you have document-oriented NoSQL databases where data, each row of a SQL table can be imagined as one document in MongoDB. MongoDB is an example. Document can be JSON format, can be XML format. Most popular format is JSON format. I'll tell you what JSON format is. Okay, you're getting the idea of what are the different types of NoSQL databases and how they're all different from each other also. Drastically different, no commonality. You're getting the idea, guys?
Yes, sir.
And then you have graph related database, so entity relationship diagram, particularly good for map like data, geospatial locations, or time related data. You can store them as graphs, a good way to represent them. Or even relationships in Facebook friends or in LinkedIn connections, you see first degree, second degree connections. Good way to represent them is by using this entity relationship way of representing using graph. So these are different ways by which you can have data stored other than SQL. So that's the crux of NoSQL databases. Let me give you an idea of the full landscape of NoSQL database and just how many options exist out there. So we have three primary cloud vendors, AWS, Azure, and GCP. All of them have their own NoSQL offerings, right? And also SQL offerings. So this will give you an idea of just how many things exist out there. And then we have some independent solutions as well, right? So let's say relational databases, AWS has RDS as a service, Aurora is another managed service. RDS is not managed, manually configured. Aurora is managed service. You have Azure SQL database in Azure side of thing. You have Cloud SQL, Cloud Spanner. Again, the difference between managed and non-managed in GCP. If you want to store data in columnar format like that Reddish, then you have Redshift over here. You have Azure Synapse for on the Azure cloud side of things. You have GCP BigQuery, very, very popular. Ashish, your camera is on. Can you turn it off? You have GCP BigQuery, where in fact BigQuery is the most popular one out of all of them. So you have these things. You have DynamoDB, Cosmos DB. Just take a look at this entire list, and you will not be knowing all of them, but you should be knowing the terms at least, so that if anyone asks you DynamoDB belongs to which database, you should be able to tell. Yeah. That's a whole line of study in and of itself, Aparna. That will require multiple things to be considered, like cost, your use cases, uh, the other services you are using. Let's say I am already using 4 or 5 services from AWS. It will be easier to integrate Redshift into my project rather than Azure Synapse. I can do that, But signups will then require additional configuration management, additional billing. I can unify my billing in AWS. That can be one scenario. Let's say I have a very particular requirement which is better handled by GCP, a BigQuery. There are strengths and weaknesses, right, that each one of them has. So let's say the strength of BigQuery particularly suits my use case. Then I will go for BigQuery, even if I have to switch cloud vendors. Or let's say I have a requirement where warehousing is needed, data warehousing. Snowflake serves better because it can handle multiple input formats. So it depends entirely on scenario. It will only come with experience as and when you handle more projects. There is no particular answer to this.
Sir, in cloud agnostics like OLAP, the last column, so there is a Snowflake and Databricks over there. So they also work as a data lake as well, right? So there won't
Yes.
needed as a structured one. They can also be unstructured data as well, like.
Unstructured still follows a structure. Unstructured mostly represents that you do not have to follow the typical table structure. Snowflake can do both. Snowflake can follow structured as well as unstructured. Mostly we use Snowflake in some kind of schema structure or with some kind of data warehousing schema. That is why it falls under this concept of structured.
Okay.
Unstructured doesn't mean you can store anything and everything. I cannot take, like, if I want, it's not a notebook that I can write, let's say, one lecture as a paragraph format, another lecture as a bullet point format, another lecture as, let's say, numbered list. That is not something that is possible or should be done. Even in unstructured, you have some guidelines to follow. It's not as rigidly structured as a SQL database. Hope that makes sense. The only form of pure unstructured is blob, as I was saying. Even SQL database supports column format, supports blob. Blob means you take binary data, put it as it is. Binary can be anything: image, video, text, anything. Bullet points, everything can be converted to binary, right? You take binary, you put it as it is. That's a binary large object, blob. That is the only true unstructured. Everything else follows some or the other structure. That is why you will find them in semi-structured or structured domain. There is nothing that is truly unstructured other than binary data. Got it?
Yeah, yes, sir. So all those products are time based uh,
All those
billing kind of
products are
time based.
not really like it's either time based or cycle based. Like for example, if you go for Hyperledger Fabric, right? There are certain like if you pay a fixed amount, you can use it up to a certain CPU capacity. Doesn't matter if you use less or till that capacity. If you use 50% also, you pay that fixed amount. If you use 80% also fixed amount, you can go for that. You can go for pay as you go model. Different options are there. Cloud payment is again very complex thing. Cloud payment, which payment options you should go for? You should never go for pay as you go, like with time, because that's almost always the costliest option. You should try to like get some kind of quotation and fix your cap for users and use within that. That's a better approach. Clear?
Yes.
Yeah, Gayatri, coming to your question, you do not have a data structure. What you do is you get the data, store it as a blob. Typically, that's where Azure Blob Storage is used, or S3. You just dump it. That's known as data ingestion. Okay. Then you do analysis on it or processing on it to convert that data into your desired format. But you have to do it. You cannot store the data in a warehouse. It is never a good practice to store it in just any format. You will have to fix a format as per your internal requirements, and then that's what data processing is all about. So that whole data engineering pipeline, right, DE, that comes in is about this. You get data from different sources in different formats or unstructured format or varied structure format. You do data processing, ingestion, then processing to convert all the different varied data into a common format, or do some pre-processing to get useful insights out of it, transform it into a usable format as per your business need, then dump it or store it in a warehouse, data then storage. So that's the whole DE pipeline. That is the need for data engineering. If data were available in a common format, then why would we need data engineering in the first place? Yes, so we create a data warehouse from a blob by processing it, and that entire process is known as a data engineering pipeline. From there, your ML algorithms and other things will come into a picture. You cannot directly feed unstructured data to an ML algorithm, right? Or to a model. You need to first convert it into a usable format, then pass it downstream into your models or for insight generation into, let's say, Power BI. Uh, it depends on the use that you have, either visualization or reporting or prediction. Clear?
Sir, and one more doubt. So there is a graph over there as for the entity relationship where you have mentioned the Neo4j and
Hmm.
Orient DB. So, do we have similar to relational databases? Is there any kind of algebraic expressions for this NoSQL as well for
No,
for
NoSQL
minimizing?
cannot be, it doesn't follow any algebra. There cannot be any algebraic expressions for any NoSQL
Okay,
databases.
okay,
The graph databases, they follow the graph theory related
okay,
concepts,
okay.
vertices, edges, those things.
So, in this case, like, how do we optimize this usage in this?
There is no optimization. That's one good thing about graph related databases is they self optimize. Any in fact, in NoSQL in general, optimization isn't a topic you will hear of very much. Only thing that you will hear of is maybe backup, ensuring data consistency. That's a bigger headache. If you're going for NoSQL, know that anything other than SQL is bound to be lesser optimized than SQL. Storage isn't a big concern for you. Processing power might be needed more, but if you're going for these databases, it's assumed you have that capacity to run that. You are going for convenience rather. You are going for something which will be used faster or better by your business. That's the reason. Optimization is only a thing mostly catered to in SQL databases.
Clear, sir. Thanks.
No, Gayatri, you don't look for patterns. You fix a pattern. Let's say I get data maybe as image, maybe as video, maybe as paragraphs, right? Use transcripts. I want to store data in a particular summary format. So I will do the processing required to get the transcript from video, put it into that summary format, or if it is an audio transcript, I will extract the or process it to get into that summary format. If it is an audio, then I will pass it through a transcribing tool to get the transcript. Or if it is bullet points, I will then create a paragraph out of it and then put it in that summary format. Reprocessing is to ensure that whatever format you desire, you get the transform the data into that format. You have now that which format that your business has to fix depending on its use. Let's say your ML algorithm feeds of let's say paragraphs of 300 to 400 characters. That's the thing you have fixed. You will transform the data that you have into that format. That transformation depends on the source type and your destination type. You will fix the destination type. You will not look for patterns. You will fix the pattern that you want the data in. Okay, hope this sets the premise of what are NoSQL databases, the whole landscape of NoSQL databases, and then what all options we have. Yes, I will leave you guys with one final things before we dive into NoSQL. I want you guys to install. Now we are going to use MongoDB. So everyone install MongoDB in their system. Now, if you go for install MongoDB, the official documentation, it will give you, you need to install MongoDB, the community edition. Other than that, nothing else is free. So I will pass on this link. Everyone take your time throughout this week to make sure that you have MongoDB installed in your system so that we can do hands-on together in the next session, right? Otherwise, unnecessarily we'll waste time here. So install MongoDB as per your OS in your system. Follow the official documentation, that is good enough. If the official documentation doesn't help you, then I will point you out to a Medium article. Uh, Here, pick the one that is 4 months ago. Do not pick older ones because a lot changes from version. If you're using MongoDB 4 versus if you're using MongoDB 6 or 7, some steps have changed. So follow, always make sure you are knowing which versions documentation you are reading. Otherwise, the steps can be a bit different. Then follow this and install MongoDB in your system. I hope you guys got the thing to do for the before the next session.
So have you pasted this link as well? that you
Yeah,
are
yeah.
showing?
I pasted both links in the chat. You can find both.
I have a question.
Yeah.
See, you just showed here three categories. Like one is structured, the other one is semi-structured and unstructured. So I
Yes.
was thinking, like, why semi-structured is required? Can't we consider unstructured everything? Like,
No,
if
it's
it's
not
all structured, it
unstructured.
should be unstructured. Why
No,
we need semi-structured?
because it is semi-structured. Even MongoDB, which we say is a NoSQL database, has a structure, JSON. It documents are in JSON format. It isn't truly unstructured. You cannot store, let's say, if I want an XML in MongoDB, it has a structure. In Cassandra, you have to follow that wide column format. So everything has a structure. It's just that that structure is more flexible than a table, like I was saying. Nothing is truly unstructured. It will be impossible to work with an unstructured system. It will require AGI, artificial general intelligence, for it to understand any kind of structure, right? So you do need a baseline structure for a particular system to work, and that's why it's semi-structured. Hope that makes sense.
Oh, okay. So we can say that in structured, like we are going very strongly into the data types and all, but here we are like little bit flexible.
Yes, yes, yes. It's like a way to understand this would be Java versus Python. In Python, variables do not need data types, right? But internally, they use data types that you know, right? It's just that for users, it is better or easier because we as users do not have to write data types. But in Java, we have to remember, know what data types to use, what is the difference between them, and all of that. But in Python, a beginner can also start without knowing data types, right?
Mhm. Simplicity. Mhm.
Yes.
And one more thing, can you please explain that horizontal and vertical part in previous slide?
Vertical scaling means when you add rows to a table, it grows down, right? Down means in vertical direction it is growing. If you are adding more documents to a MongoDB database, it is growing sideways. Like think of it like this. Documents means think of a folder in your system. When you're adding new files to the folder, it is growing sideways, right? New files are being added. If you have it in that gallery view, it will show up new files to the side. Versus in SQL table, if you're adding new rows, it will only grow down. It won't grow to the side because you have already fixed the number of columns while creating the table at 10 or 15 or whatever. There is no chance for you to add a 16th column after you have added or for a new row. It will always have at max 15 columns. So
Got
that's
it.
why vertical scaling and horizontal scaling. Got it?
Yes, yes. Thank you.
Uh, See, Windows x64 or x86 will depend on your system architecture. If it's yours is a 64-bit system, go for x86. If it's a 32-bit system, go for x64. But having said that, doesn't make a difference actually for MongoDB. Go for x64 or x86, it's fine. It'll all be result in the same installation. Got it, Ashish? Okay. So everyone should positively install MongoDB and please pass on these two links in your groups as well for people who haven't joined. I want them also to uh, have this info and install MongoDB. Otherwise, they won't be able to catch up with the sessions. Sometimes it might create a few issues when installing MongoDB. Just make sure to Google a bit. It's the resolution typically is pretty simple, not a complex one. And then try to use MongoDB or see that it is booting up. That's all. Rest everything we will do from scratch in the next session. How to create a database in MongoDB, how to create a document in a database, all of that we will be seeing, and the Mongo query language as well. Clear, guys?
Yes.
Okay. And please convey to others as well. I would like a bit more attendance in these sessions. I'm not understanding why it's below even 15 today. It's a bit of a concern. Was it conveyed that it would be a NoSQL session today?
Yes, it was there in dashboard.
Okay.
But
Wasn't
I
Gayatri?
I mean,
the
I mean,
time
it's like, so I
was
mean, like mostly we don't like frequently go to LMS and check that. So I mean, yeah.
Mhm.
So and
Okay, you
it's
can
like
let everyone else know also.
yeah, we'll know that
Next
about
one.
the next session. Yeah.
Yeah, next one will be a MongoDB hands-on session.
I
So if,
feel like people are returning from office and also
Yeah,
maybe
even that is the one.
yeah.
okay, but still we typically have more than 20 people in previous sessions also. Today is it's a bit lower than normal as well. That's why I'm a bit concerned.
Yeah, I mean, so when is the next session? Like maybe not
Next
even
Tuesday.
just
Next
next
Tuesday.
Tuesday. I mean, so yeah,
Yeah.
we can keep a reminder so that I mean people can be available because it's mostly office hours. So and
Yeah.
most of us works for a US firm and all those things. So mostly
Oh,
this, during this time we have meetings and all those things. So it's very difficult to. So mostly people go with the recordings instead. I mean, just joining calling. So.
okay,
But
got it.
we'll convey them so I mean so that they can be available for next Wednesday, Tuesday.
Sure. Okay.
Yeah.
All right. Okay, then please have MongoDB installed, guys, because we can do hands-on in the next session. And MongoDB typically is a very small subject as compared to SQL. SQL has a lot of concepts before you can dive into the hands-on. You need to know a lot of things, relations, foreign keys, these, that. MongoDB is relatively straightforward to work with. That's the reason it shot up in popularity around 2015-16. It's relatively beginner friendly. So it won't even take us long time to learn and use MongoDB in your projects. So one session should be enough for the hands-on. So please ask as many people can attend. That will be good. Yeah. And thank you all for attending during weekdays
Sir,
as well.
thanks for this class actually. So it was very helpful for us. But I just have one doubt. Can you just explain those acid and base concept over there, just in words without
Which
presenting?
which one? Which one? I didn't
The
catch that again. Sorry.
acid and base. The SQL you said it is an acid.
Acid.
Yeah, yes. That
Yeah. Okay.
transparency
Aha.
concept. Yeah.
I'll show it to you with example also. Basically, acid property means atomicity, consistency, isolation, durability. They are built into SQL. That means you don't have to put any extra thought. If you're using SQL, you get these properties, right, out of the box.
Yes.
Like if you're using Java, you get OOPS concept out of the box. You don't have to put any extra thought into it.
Yeah.
While using NoSQL, you do not get this. None of the NoSQL databases gives you this property. So they have to market themselves, right? Actually, MongoDB was the pioneer of all of this marketing jargon. So instead of acid, they came up with the term base.
Yes.
Okay.
Okay.
So there is no advantage there, unlike acid, that you get with them. I'll tell you the full form of base also. It's
Mm.
basically available. That it says that the data will be available, but we can't guarantee that. S for basically available is BA, and then S is for soft state. The system state of the system could change over time. That means today, let's say you have 50 documents, and horizontally it is looking like, let's say, imagine it is 10 centimeter wide horizontally.
Mm.
Tomorrow it might be 100 centimeter wide, so the performance can change. So the state of the system is soft, not rigid. And eventual consistency, like I said, it's just marketing gimmick, to be honest. It's no
Oh,
real advantage.
okay. So, answer in SQL, the query optimization is not being done by us. It seems to be in previous session you have discussed that
I
next
will do
session.
this after NoSQL. So after these two sessions, we'll wind up with a bit of query optimization,
Yeah.
and we'll couple that with maybe stored procedures as
Yes, sir. So
well.
in this case of you, we do have a NoSQL in our database. So hence it has not been covered so far. So in this case, if you can suggest me what to just to go through on an exam basis, like, so what did you suggest actually, sir?
For reading up on NoSQL,
Yeah, yes.
I'll give you a link. Where is it? Yeah. For exam, I think the things that you need Java deployment should be good enough for studying up on NoSQL. Just for because it has definitions and all that you can write in exam. It will come in your exam.
Yeah, it is in our syllabus.
Okay, then follow Java deployment for reading. But for practical hands-on, I wouldn't recommend this because its examples are too simplistic. Actually,
We are also not sure, sir. Like, so whether the questions will be on basis on this no SQL or not, because it is not
it will
been
be
covered.
and very less. Don't worry. I can tell you.
Okay. Thank you, sir.
Okay. Most of them will be on the concept of SQL, like normalization,
Okay.
then constraints, all of that.
Constraints. Okay.
ER diagrams, one or two. You will find questions like that.
Okay.
Okay, Gayatri. I'll see if we can squeeze
Sorry,
that
sir.
in.
One last question. How much more classes will we be having?
As many as required, but when are your exams? Any dates
Like
yet?
next week is the last week.
So we are getting into immersion on 7th.
Yeah, I heard of that. Wait, let me check the calendar. So you're getting immersion from 7th to, so we only have one Tuesday. Okay. What I'll do is, okay, for you guys, there is a 4th and there is a 6th. Okay, so we have two. I'll probably take both the add-on sessions next week, okay? The one on
We will be
Tuesday.
traveling, sir, like on 6th, most probably.
Yeah,
Everyone.
sir.
Okay.
Everyone will
Okay.
be.
Yes, if you have to be there on 7th, you will have to travel. Okay, that's a bit of a challenge. 7th to you guys will be coming back on 17th, I heard, right?
Yeah, yes, sir.
Okay,
16th is our last date and 17th we will be returning.
will be returning. Okay, then can we do one more session on 18th?
Yeah, sure, sir.
Let me check the possibility for a session when you are there in IIT Jodhpur, maybe in person. Let me check.
In
I'm not
person.
sure.
You will
I
be
have to
also there.
Hmm?
You will be also in campus, it seems, sir.
No, not yet. I'll have to talk to IIT and get the approvals and all. Let's see. That's why I said I'll have to check. I'll update you by the next session, okay? Or before that, possibly through channels.
Can we have lectures in this week, like tomorrow, or
I
we are
think you
free
have one
tomorrow?
more.
So, and
If
sir,
you have
Python
time.
is also completed, it seems. Only matplotlib is pending because Simran has covered for pandas for the last week session for an
Hmm.
add-on session. So only matplotlib is there. And yeah, yes, sir.
Okay, then let me see if I can take the Thursday session, this week Thursday session, okay? Let me check.
Sure, sir.
You'll get the information by tomorrow.
Sure, sir.
Okay, sir. Thank you.
Thank you.
Okay. All right. Thank you, everyone.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Bye.